So the first of the two scales is the correctly spelled here for some reason, Richter scale. So this is the person, I forget his first name, but this is Mr. Richter. Um, oh, Charles Richter. I can't even read. So the Richter scale is also known as a logarithmic scale, and particularly it's base 10 logarithmic. Um, Now, for those who don't do math, it might seem a bit weird, these definitions. So it's a base 10 logarithmic continuous scale. So what does that actually mean? Well, base 10 logarithmic means that every whole number up is 10 times stronger than the next one. So if we have a Richter of 6, that is 10 times stronger than a 5 is 10 times stronger than a 4, but a 6 is 100 times stronger than a 4. So each number you go up, you're essentially increasing by a factor of 10. And continuous means that every number is included, including decimals. So you might see like a magnitude 9.1 earthquake. Um, the one in Japan, I think, was just a regular 9, but I think the highest one ever it was in Chile, and I think it was 9.5. But yeah, you can have decimal points, although it's usually truncated to 1. So that's really it. Richter scale based on logarithmic, which is continuous and no upper bound. So you can go as high as you want, but by the time you get to like Richter 12, the Earth just shatters itself. So it's usually up to about 10 is the realistic limit. Now the next one, as I said, is the modified Mercalli scale. This is the person who theorized it or came up with it, Giuseppe Mercalli, in the 1900s. So this was in and around the 60s, or I think 50s or 60s when the Richter scale was invented. But the modified Mercalli scale, um, it was originally called the Mercalli scale, but things had to change. So, unlike with strength of an earthquake, the Mercalli scale actually just measures the factor of destruction caused by an earthquake, and it doesn't actually account for any energy or plate movement. So, as I said, this is Giuseppe Mercalli here. It originally ranged from 1 to 10 in Roman numerals, but then was later expanded to 12, giving the modified part of the modified Mercalli scale. The only problem with this is that it's very open-ended. Um, However, it actually can be used to estimate the destruction of historical earthquakes. So, as in one might have caused the 79 AD eruption at Pompeii, might have sourced historical data, used the Mercalli scale, and then sort of backtracked to either the Richter or moment magnitude. Although that would have been very difficult. The Mercalli scale is great for these sort of historical earthquakes or anything else really. I forgot to mention the only difference is that this is actually a discrete scale. So you can't have like a 1.5 because of it being Roman numerals. The Romans, didn't really like decimals. They used S for a half, but it's only whole numbers here for the modified Mercalli scale. So in summary, the Richter scale measures continuous data and energy released. There is one fixed value for the scale. So, like obviously, when scientists measure things, they have to agree on a particular value, and they usually do. There's sort of a universal, not really standard, but universal agreement on how to measure them. As I said, one magnitude is accepted internationally. However, the modified Mercalli scale measures data discretely and measures rate of destruction rather than energy released. The only problem is that it's not a universally recognized standard. It can vary due to different people giving their opinions on what they experienced, but it can be used to measure and model these sort of historic earthquakes that might have happened that might have been impossible with the Richter scale.